Alright, so firstly we will talk about what is the internal combustion engine. An internal combustion engine is a device that we use to convert chemical energy of fuel into the chemical energy through controlled burning, which is combustion inside a chamber. And the high pressure gases will be created to push the components like piston to generate the power. So now we'll be talking about the function of internal combustion engine. So the main function is power generation and control. The combustion inside the cylinder causes the piston movement, which produces rotational motion at the crankshaft. Engine speed and power are controlled by adjusting the fuel and air supply. So in addition, the several supporting systems will ensure the efficient operation. The cooling system removes excess heat, the lubrication system reduces frictions and wear, and lastly the exhaust system expels burn gases safely. In conclusion, the internal combustion engines are essential in many sectors, converting fuel into useful mechanical power efficiently. And now let's moving on to the applications of internal combustion engines. In transportation, the petrol engines are used in light vehicles such as cars and motorcycles, while the diesel engines are used for heavy-duty vehicles like trucks and buses. These engines provide a high power output and reliable propulsion. And in industrial and power generation, internal combustion engines are used to drive machines such as pumps, compressors, and construction equipment. They are also widely used in diesel generators to provide backup power or electricity in the remote areas. And for agriculture and domestic use, these engines are found in lawn mowers, chainsaws, and portable generators. They are especially useful in rural areas where electrical access is limited.
So, what is first law of thermodynamics? It stated that energy cannot be created or destroyed, it can only be transferred or transformed. So basically means that energy is conserved. Based off of this law, we can actually derive an equation which we will get that the change of internal energy is equal to the heat added into the system minus the work is done by the system. So let's take for an example a hot cup of coffee that is put inside a room with room temperature. So we know that if the coffee is hot, means that the kinetic energy of the coffee molecule is very high. So when the coffee becomes cold, the kinetic energy of the molecule loses some of this energy. And where does this energy goes? It goes to the surrounding, and we can say that the energy that is lost from the coffee is the same that is gained by the surrounding. So moving on, one of the most popular model of the first law of thermodynamics in internal combustion engine is the ideal Otto cycle. This actually helps engineer to understand the four-stroke engine, and we can see that there are four stages in four-stroke engine. The first one being is the isentropic compression, where the piston actually compresses the mixture, hence the work is done on the gas. Then comes the combustion stage where the fuel is burned rapidly. And in this stage, you can clearly see that the chemical energy is transformed into thermal energy. In this stage, also, we can see that there is a jump in pressure and temperature as shown in the diagram from 2 to 3. And then we go to the expansion where the hot gases pushes the piston and the gas does work on the piston. This is the stage where the useful mechanical work is produced. Then lastly is the heat rejection, where basically the heat and energy leave with exhaust gases and some energy is lost as waste energy.
Hello. So, have you guys ever wondered why engine gets so hot even though its main purpose is to move the vehicles? So, this is where the second law of thermodynamics comes in. So, the second law of thermodynamics explains two important things that are the direction of the heat transfer and the limits of the energy conservation. So, heat naturally flows from a hot region to a cold region, and it is impossible to convert all heat into a useful work. So in internal combustion engine, fuel burns inside a cylinder and produces an extremely high temperature heat. This is when the heat pushes the piston downward, creating the mechanical work that moves the vehicles. However, according to the second law, only part of this heat can be converted into work, and the remaining part of heat must be rejected. So as this happens, entropy become increased, meaning some energy become unusable. So this is why no internal combustion energy can ever reach 100% of efficiency. So no matter how advanced design is, you can never approach 100% of efficiency. Moving on to the part of entropy generation in internal combustion engine. So entropy is generated due to the irreversible processes such as fuel combustion, friction between moving parts, and heat losses to the surroundings. So this irreversibility causes some energy to become less useful for the producing work, which is explained why real engines experience efficiency losses. So, to analyze these losses, engineers use exergy analysis, which is based from second law of thermodynamics. Exergy analysis help identify where useful energy is destroyed and how engine efficiency can be improved. Okay, so I'm going to explain about the thermodynamic analysis of internal combustion engine, which are more focusing on the Otto and diesel cycle, which are the fundamental models in engine thermodynamics. An internal combustion engine operates as a heat engine, which are converting the chemical engine of fuel into the mechanical works in occur for the first and the second law of thermodynamics. So in the Otto cycle, it uses in the spark ignition engine, which is consists of two diabatic processes and two constant volume heat transfer processes, with the efficiency mainly depend on the compression ratio. On the other hand, the diesel cycle used in the compression ignition engine, which is features constant pressure combustion, which is allowing higher compression ratio and typical higher efficiency. In real internal combustion engine, efficiency is usually lower than the ideal due to the heat losses, friction, and incomplete combustion, which these engineers use thermodynamic analysis to identify where are these losses occur and to improve the engine design. Important parameters such as pressure, temperature, and volume change throughout the engines is need to be determined and need to be taken, and the work produced by the engine is represented by the area under the pressure volume diagram, while heat represented energy from the fuel or lost to its surrounding. So by understanding thermodynamic cycles such as Otto and diesel cycle, engineer can predict engine behavior, recognize efficiency limit, and also design more better engine that can operate more efficiency with lower emission.
So, in conclusion, thermodynamics application is very useful when designing internal combustion engine, where it actually helps engineers to understand how chemical energy is converted to mechanical energy. Next is also the first law, where it also helps engineers to understand how energy is balanced, as shown in an example of the ideal Otto cycle. Then in the second law, it helps to understand how and why energy losses happen, which also states what's the reason real engines are less efficient than ideal cycles. Then lastly, it is also able to identify performance and improvement in the internal combustion engine. So that is all for our presentation. Thank you so much.